Section 8. Testing and Security. In this section, we're going to learn how to write great unit tests. We will also look at UI tests and how to write great UI tests. We will then use those UI tests to create screenshots of our app automatically. Later, we will use the iOS keychain to securely store a password of the user. And in the end, we're going to test that critical part of our app with another unit test. How to write great unit tests. Unit tests are essential for writing great apps. Why? Because they automatically test critical parts of your code. The best thing is, you can always rerun those tests whenever you make slight changes. So you can make sure you didn't break any of the existing functionalities with your changes. I would say, let's get started. Now what we're going to do for this video is we're going to build again up on our journaling app that we have developed in section 1 and section 2. Now you can use more or less any of the last existing projects that we have done. I'm using the last project of the video 3, where we still were using a model that was read out of a JSON file. And if you can remember, where the entry class struct had a sample entries variable, where we were actually reading that JSON file. Now let's get started. So a unit test in Xcode is called an Xcode test case, and it's a subclass of Xcode test case. It has a lot of handy variables right out of the box, like this setup method. That setup method is called before every single test case. Then there is a teardown method, which is called after every single test case. Now a test case usually is a function that just starts with the name test, and the rest of the function name describes what exactly we're going to test in this function. There is also one more setup method, which is, if you look closely, an override of a class function setup, which is only called once per the whole test case. So it's run before the very first test function is called, and then it will no longer be called. So very nice and handy for some setup. And the same thing exists for teardown as well. Also, if you pay attention here, the class keyword, which means it's only called once per whole execution. Now we're not going to use that. That's just as a side note. To begin testing, one of the most important things is up here, you have to import your app's classes. And you do that basically by writing @testable import and then the name of your app. In our case, journaling app. Now, if you don't do that, you don't have access to all the classes you want to test, and therefore that doesn't make a lot of sense. Now, what we're going to do, we're going to write a method where we are going to test if all our entries have unique IDs. So let's call that test unique IDs. For that, let's first create an instance of our model. And as entries, let's pass the sample entries. Now, it's a rather interesting programming exercise on its own to find if there is any duplicate in an array. So if you want, you can now pause the video at this point and try to implement it yourself. I'm just going to implement it here, and you could later check if your implementation was right. Otherwise, you can just follow me on this one. Now, I'm going to use a IDs array, and it will basically be the model's entries, and I will use a compact map to extract or to convert every entry into its ID by saying $0.ID. Here obviously have to write entry model. Now what this compact map does, it maps every element, every entry, and the returning array, the resulting array, is basically an array of strings, so it will be reduced or mapped to just the ID property. Now then I'm going to iterate over the IDs, and I will filter out every element that has the same ID and count it. So whenever there is a duplicate, whenever $0 equals ID, whenever the ID property is contained more than once, the count will be bigger than 1. Now what you always want to do in your test cases now is you want to make sure that the count variable in this case is the value that you expect. And you do that by writing Xcode test assert, in our case, equal. The first part is usually your expected value, in our case 1. And the second is count in this case. So whenever our count is 1, that's what we expect, and then we want the test to pass. Now you can also add a message that should be printed when the assertion does not return true or is not fulfilled. In our case, we could name that found duplicate IDs. Now running our test case, that can be done in one of two ways. You can either click here on this symbol here, that will change into a play symbol once you click over it. Or you can also move to the test overview here, where you can simply run either all tests or all tests of this specific test case, or again, the individual tests. So let's try to run that. What's going to happen is the simulator is going to be launched. The app is going to be executed on the simulator, and then the test will be run. Now the simulator itself is not interesting during test cases. There's nothing really you can see. It will just open up the app and run the test case. All right, so that might take a while, but once it's up and running, the test will run, and then you will get this nice little animation here that tells you that the test succeeded in our case. So that means we have no duplicate IDs. You can also debug test cases, of course. So you can see what the individual values are at each point. In our case, we could use the console here to print out all the IDs and manually check there are duplicates, which we can see that there aren't. Great, so let's halt the execution for once. I want to tell you one more insight on testing, and that's also already one of the pre-defined methods here. And that's the very handy measure function. Now with the measure function, you can basically test the performance of certain parts of your code. And that's very handy for performance critical stuff. In our case, just to demonstrate, we're going to implement a for loop that counts to 100. And then it just gives us, let's say, 10 to the power of I. Now we're going to run that test case once. And the first time you run a performance test, nothing really happens. It just says here now, no baseline average for time. You can click on this symbol here, and you see the test case in average was executed in 0.00015 seconds, and you can now set that as your baseline. That means whenever the performance deviates by more than 10%, the test case fails. Now let's add 3 zeros here. We should now have made the performance significantly worse. Let's run the test case to confirm. And as you can see, our test case now failed because our time average was 70,000% worse, and a maximum of 10% is allowed. Now, I hope this was a great introduction on how to write great unit tests.